This will be a quick video on making a Lora for creating consistent characters using Fooocus user interface. Search for Kohya SS. You will find a GitHub project like this. Click to open. I will be using this application for training a Lora. Here are the requirements to run the application on Windows. There is a direct download link given for the needed Python version. Click to download. Running the installer, you will see something like this. Make sure to check it Python to path, and then just click Install Now. Once the installation is complete, you can verify the installation, and the path checkbox we check is working. Type Python --V, and you will see the version installed. The next is CUDA Toolkit by NVIDIA. Select the fields to download the correct installer based on your computer and the operating system version. The file is of 3 GB, may take some time to download, but the installation process is simple. We can just click the next button. This is required, but I don't think so. I will be needing this. I will remove this later. The third requirement is Git. We can get the work done without this, but using this will help us manage the version and getting it updated in the future. The installation is simple. We can just click Next to install. The last is some packages or some C programmed code, which I don't understand much. It's already present on my computer, hence the message. You make sure to install it. I will check the installation before starting with Kohya. Open the command prompt in the folder where you want to install the Kohya application. Copy the link to make a clone of this project. Type git clone, and after a space paste the link copied and press enter. In my case it already exists. Let me create a temp folder for this example. For me, I will go to the temp folder created and run the same command again. The clone command running will exit, and if you check the folder, the application will be found cloned from Git. You can always download the zip file from here and unzip in a folder, but you will be having problems while updating later. Using Git will let you have the latest code whenever you want. Double-click the setup batch file to start the setup. It's creating the environment in which the application will install its utility files and run its operations. Once environment is created, it will give us 7 options. We will go for the first and second option followed by 6th, which will run the application after installation. Press 1 and then enter to go with the first option. This will start downloading some utility files. This will take some time as the file sizes are large. Install the CUDA from the second option if you have a NVIDIA 30 or 40 series cards. After installation, we can select the 6th option by pressing 6 and enter to submit. This will open a new window, and we can close the older setup instance. The one in front of us is the Kohya application, which we need to keep open till the time we use the application. The application is running, visible in the browser. We will be training the Lora in this section. Out of all these options, Lora and this utility section is what we need to understand for now. To train a Lora, we need some images of a person. For this example, I will get an image of the famous actor Alexandra. To get a high-quality image, you can do an advanced search in the tools. There are multiple filters here including image sizes. I will be selecting 2 MB images to get a good quality image. This will take some time because the image size is 2 MB, but the details are not up to the mark. You need to go through lots of images one by one. You can question yourself, would I be happy if the Lora produced an image like that? This image. This will not work because there are 2 people. The second thing you can ask is if the image has something odd that the computer could find confusing, like multiple persons. Even this is computer generated. This requires some degree of experience to get right. Keep in mind, you need a clear image of the person, something not too far outside of the ordinary. After spending some time, I gathered 15 images for the training. My training dataset of 15 images is less, but will work. I had my training data in a file by the name Alexandra Daddario. The way I used it for training is by creating a folder named train into Kohya application folder like this. You can do the same. There are 4 folders: img, log, Lora, reg images. This config file can be ignored. I will delete this. The img folder will have the training dataset we collected from the internet. This is the log generated while I was testing with different settings to generate Lora. This is where the Lora file is saved after training. This is after testing with different settings. Next, reg images folder is for regularization images. Lots of images for reference while training on the given dataset. I will copy the image folder and paste it into img folder. We have our 15 images. I also renamed the image numerically because I read this in some blog. I do not know if it has any impact. Shortcut to rename is F2. The Lora will be used in the text-to-image process, so the dataset we are giving should also have some text referencing each image. Now, I have to create 15 text files and write something into it that should speak about the image. Quite a boring and tedious task, I will say. But this is where the captioning comes in play. In the Utility tab, there is an option named Captioning, having multiple options under it to generate captions based on the image. I will be using the blip caption option to generate the text file and caption of image I spoke about. I will give the image path and let the file extension be .text. The other option can be kept as default. When click to caption the image, the program output will be visible in the command prompt. It's downloading a model to generate the caption. I deleted the previous download because my C drive was almost full. There will be more files around 15 gigabytes to be downloaded while training. After the download, the caption got generated in seconds. Let's check the results. If someone else has a disk space issue, then you can clear the file at your risk, from the folder named user, your computer name, and then .cache file. There is one more folder named pip, which may have a large Python library. I deleted files of this application because it can download automatically when it is needed. Coming back to our topic of caption, 15 text files have been generated, each for their respective images. Opening the first file, it has text: woman with long brown hair and blue shirt. If we check the image, it matches the image. These captions are generated by a computer. However, you can verify the text for any mistake and make it correct as per your understanding. This will impact the image generation and response to the prompt we give for generating an image. Let's look at the training section, where we will be training a Lora. Do you remember? I deleted one of the config file a few minutes ago. That file goes here. I had a copy of it. This file has the settings. If we upload this file, all the settings will be applied and we can start the training. I will be sharing this file, but it's also important to understand what happens when we change the settings. Let's look into it. In the next section, there is this one option: mix precision for the weight data during training. I will keep it simple. Cards older than 3000 series select FP16, and 3000 and 4000 series select BF16. My 4060 worked fine with BF16. This will also download some huge files into the cache folder. The remaining setting here can be kept as it is. In the model section, we need to select the model we are preparing the Lora on, that is, SD1 or SDXL. I will be selecting the XL version of Stable Diffusion, and we are making this for Fooocus, which supports the XL version. Here we need to specify the name of the Lora. I will write version 3. Next, the dataset, the images downloaded for training the model. I will specify the path. This is where the 15 images are. I will give the path to the img folder. That is the parent folder of this folder. Because it's asking for a folder containing a subfolder, img folder should be selected here. Dataset config is optional, and training comments can be ignored. The format type to be saved will be SafeTensor and Precision as selected above, BF16. Next, metadata can be skipped. After that, folders need to be filled. The folder where we want the Lora to be saved. Next is the log directory. This regularization images helps a neural network to detect more general patterns and improve its overall accuracy. Here, I have multiple images for reference to identify the patterns of a woman's structure, which can be helpful while training a Lora, learning for more detailed image. This thing will double the training time. However, this is optional. The image folder here is in gigabytes. I will be sharing this somehow, but I need to think about it. Data preparation is not needed. We already gave the necessary data to the application. This parameters section has too many options, and I am still learning, but I can explain you the important fields which are very important for Lora training. Basic, Advanced, Sample. I will not be covering this. Let's look at the basics. There are too many knobs to tweak and turn. However, we will be covering the main options essential for training. Like this option, titled Training Batch Size. Specify a batch size. A batch is the number of images to read at once. If multiple different pictures are learned at the same time, the tuning accuracy for each picture will drop. But since it will be learning by capturing the characteristics of multiple pictures, the final result may instead be better. We should also note that, the higher the batch size, the more memory is consumed. Epoch here specifies the number of sets of learning. This is important. Let's understand. In my example, I want to train a Lora by reading 15 images, each 20 times. In this case, one epoch is 15 times 20. That is 300 training steps. Similarly, if 2 epoch, this will be repeated twice, so it will be 300 times 2. That is 600 steps. Note that, the units I said here are number of images, repetition, epoch, and steps. There are 2 more units to be noted, train batch size and epoch steps. Let's understand where these units are placed. In this example, I'm using training batch size 1, meaning 1 image at a time. Taking multiple images at the same time will affect training time due to change in epoch steps. So, if we take 2 images, the calculation will be 15 images times 20 repetition, divided by 2 images at a time. This gives us 150 epoch steps instead of 300 steps we saw before. This will take the maximum number of epochs for training. The training will always end when the number of epochs specified here is reached. We can leave this blank. Training steps. You saw just now how we calculated 300 and 600 steps. This is to specify the maximum steps in training. I hope you understood this part. Save every nth epoch is about saving a Lora after every epoch completes. If we keep the value 1, in our example of 600 step, output folder will have a Lora after completion of 1 epoch, and a final one after 600 steps. This is about the caption file we generated for 15 images. It was a text file, so this is correct. This learning rate is interesting, but I was not able to use it. It needs a bigger graphic card. I wonder if a 4090 can handle this. It specifies the thickness or the weight of the wiring in the neural network, adding up more information while training. Enable bucket is an important to be checked. When your training dataset has images of different sizes, It will categorize the images based on their size into buckets, so it becomes manageable while training. Note that having images of different sizes will add a process of increasing or decreasing the aspect ratio to a unified size for proper training. Max resolution will be 1024 by 1024. Larger images in the dataset will be adjusted and trained accordingly, and we are making Lora for SDXL, which is trained on the images by 1024 pixels. So, I will just run the test and explain to you some information here. I have made a few mistakes here. I forgot to specify the repetition steps I explained while calculating the epoch steps. To specify the repetition, we need to rename the folder. The folder containing training images should start with the repetition count. In my example, it will be 20, then use underscore instead of space between letters. I will quickly start the training. I will use the config file to get the settings. Next, I will have a look at the parameters. Before that, I will change the output of the Lora name. Else, this will be again an error. I will leave the rest. I will keep the epoch to 5. So, it will be 15 images, 20 repetitions, and a total of 300 steps. It is said to keep total steps between 1500 and 3000. So epoch will be 5, which makes it 1500. Maximum steps will be 1500. Save Lora after 5 epoch. It looks okay here. Let's start the training. These are the commands to be ran after we click the train button. You will see the values we selected above: repetition, images, and total steps. The training process takes quite a hardware. Let me show the resource occupied. There are times when my 16 GB RAM goes 100%. I used to close the browser at such times. I am using a different potato PC and a capture card to record this video, so you can get the clear idea of the hardware needed. Is my background changing color based on workload? You will see this is the training setting, and the epoch has begun. The first is in process. This is the completed steps and the total steps. Steps completed in 6 seconds. The average on my computer is 5 to 6 seconds. If multiplied by 1500, you will get the ending time. Then you can decide for a sleep or some other stuff. Graphic card 16 GB is completely occupied, but the training in the same setting works on 8 GB cards as well. Memory consumption will remain constant now till the training gets completed. The 10-year-old CPU was fine the entire time. Let's check the Lora. All settings are default. My prompt, as always, a woman. So, it's working like normally it does. Let me add the Lora and generate again. It's the same. Increasing the weight should work. I will increase the weight to 0.9 and try again. The results are good as expected. The actor's face is perfect. Let's try the prompt from the previous video. That is where the Lora training topic started. So in the previous video, we saw the AI was not able to generate the accurate person from a different angle, and the chick area was the problem. Well, there is a problem here as well, but that is just me due to time constraints. Look at this area. This image could have been better if I had just collected more images and at least one image of restaurant. Let me show you in a better way by asking for an image wearing blue jeans. Bad image. I will try again. It's the same again. Now you can see, my training image did not have any photo of legs. Well, it has one, but I don't think this image could help us. You got my point, right? The image to be gathered should be at least somewhere near to what you want. The images I collected had mostly faces and shoulders, based on which the results are good. If you remember, I spoke about regularization images. Images generated by using regularization images and without regularization have a difference. The regularization Lora image has better results. I checked multiple times. The results are mostly better. But it does adds up a considerable amount of time in the training. You can try making a dataset using image prompts for multiple images. Make sure images are identical at least 80 to 85%. Now, I'm not an expert. Still learning. I skipped a lot in this video. It will easily take 3 to 4 hours to explain everything. Also, the documents are a year old and information available on the internet is sometimes misleading, so this needs to be tried out for the best possible settings. For consistent character, yes, you can surely get it done, but the consumer hardware we are using is not meant for this kind of work. You have to rent big graphic cards to get the finest result. Maybe in future if the channel gives income, I may come up with the best settings and Lora at the best cost. Or else I can test on multiple cards. I bought this domain and hosting to share regularization images. I do not own these images, but I can't even share the link of such websites. If the images are removed from my website, then check the description. That's all I can do for now. By the way, I'm testing an application which is Fooocus plus Flux combined. Are you interested?